who am I? Rijk van Zanten. Didn't make that up. I know, right? Dutch born and raised, developer, designer, now based in Brooklyn, New York. Got my start a long time ago as a user experience designer, hence the hat. In college, got into front-end development, shortly after that. I've since worked on data-driven apps and websites ranging, small local schools, nonprofits, but also big Fortune 500 companies. And while doing that, I started working on a data management system to help power those projects. I've since joined forces with Ben Haynes, now our CEO, to create what has turned into a sort of unified data hub powering tens of thousands of websites and apps worldwide, Directus. So for those who haven't been to the booth yet, I think I've spoken to most of you at this point, but Directus is a data management system, meaning you can use it for a wide variety of data-driven use cases. Think website content management, CRM, product inventory management, etc., etc. Kind of the best of a CMS, best of a backend as a service platform. So it is a Vue built. I keep going back as if that screens are over there. It's a Vue built on the sides. Admin app to manage your database's content, and then a set of REST, GraphQL, and WebSocket APIs to then programmatically get access to that data from your Vue frontend, or any other app, really. So while building Directus, we've learned lots and lots and lots of things. Because it turns out building a platform that tries to do so many things, surprisingly difficult, right? Tons of different use cases, which means there's a ton of different expectations, tons of different users, and a lot of hopes and dreams around how data is presented and loaded, especially when it comes to performance. So we've had a couple other keynotes today around performance, fascinating subject. But what is it, really? Right? When talking to developers like you and me, performance is often thought of as the objective measurement of speed through tools like, the performance step in DevTools or Lighthouse. And that way of measuring performance is a great starting point to verify the usability of your app. Because after all, fast is good, right? Fast is good. Nobody likes to wait around for things to load. I think this is sort of a universal standard. However, what does performance really mean to your end users? They're not going to be looking at the DevTools, right? They're not going to be, they don't give a rat's ass that you scored a 98 on your Lighthouse exam. So what users really care about is how fast or responsive your app feels to use. In other words, the perceived performance of your app. That perceived performance is very subjective, influenced by a lot of different outside factors, like the user's physical location, the device they're using, mental state, a little bit more on that soon, the exact device, screen sizes, etc., etc. So to give you an example of the difference there, on my way here, New Orleans, shout out first time, I looked up the very quickest route from my apartment in Brooklyn to the airport. Simple stuff. Pulled up Google Maps at my apartment. Felt great. Very fast and responsive. You type in JF, case immediately shows up, auto-completes. Click the thing. Directions show up immediately. Great. On selection of those, on the suggestion, directions show up in what feels like the blink of an eye. Generally good experience all around, right? So equipped with that knowledge, I'm like, okay, what is the train I'm going to get? How do I get to the airport? I set off on my way. Now, I don't know if you've ever been to New York City or if you're from there. This is the status quo, unfortunately, most of the time in my neighborhood. Train I was supposed to get, nowhere to be found. Just didn't exist all of a sudden. Poof, happens. And it wasn't really looking like it would show up at any time soon either. So what do, right? Suddenly, out of nowhere, another train showed up, a line that usually doesn't even go through this station in the first place. Could I still take it? I don't know. Pulled up Google Maps, once again, this time on my phone, right? Previously helpful auto-suggest, this time refreshes the thing right before I tap the thing. So now I'm fumbling. I'm like, shit, wrong directions, try to close it, try to type in the new thing, right? See those train doors closing? It's like, where do I don't know. Frustrating. So I figured, worth the risk, need to get to the airport, I'm gonna go anyways. Screw it, we'll see what happens. Well, on the train, I'm like, all right, game over, no more internet. Again, subway station in New York, you have Wi-Fi for about 30 seconds and then not for about 3 minutes and then again, right? So I figured I'll wait until the next station and we'll see what's up. But to my surprise, Google Maps offloaded, sort of offline downloaded that map of my local area and was able to give me the directions anyways. So even though I was doing the exact same steps twice, right? Just look up, how do I get from where I am now to the airport? And it did so in an environment with about the same measured performance at first, because my home Wi-Fi in Brabant is about as fast as the 5G that I had in the neighborhood. The experience and the perceived performance was incredibly different, right? And that's just due to all of those external factors now. So how do you deal with all of that hard to measure, very subjective stuff? It's really all about setting expectations, right? Because depending on what you're doing, that loading of that data can take anywhere from a blink of an eye to eye-wateringly long, meaning that you have to inform and engage your user in such a way that they know what to expect from your app at any given time. Sometimes that can take the form of a loading spinner. Sometimes it means educating your user ahead of time that they know what to expect. Sometimes you got to be a little bit more explicit. I hope for everybody who's seen these reviews, it's fantastic. And then it fills. Oh man. One way to set your expectations, just tell them up front, this app is going to be slow and kind of going to suck. Good luck. But what is that fasting, right? What does it mean to be fast? Let's set our own expectations around what fast means in UX. For most of your users, there's a fairly consistent amount of windows of time associated with the states of somebody's attention span. It's a bit of a moving target though. As technology evolves and gets faster, people's expectation of what fast is will also change. But generally speaking, these have been almost universal truths around, what sort of timing we're talking about. Generally speaking, anything less than 200 milliseconds or so feels like it was immediate, right? Instantaneous. It's like you blink of an eye. I feel like when you blink, it is about 50 to 150 milliseconds. So it's literally blink of an eye fast, right? Things that are a second or less, you're still actively in control with what you're doing. It still feels like you're actively engaged all the time. But, once you hit that multiple seconds, you really got to start showing people actively, everything still works, we're still doing things, everything is good, but, get them involved. 10 seconds or more, people are distracted, gone, right? They'll come back later, hopefully. So how deal? Because oftentimes, you really can't control the performance, what's going on underneath. So just a quick show of hands here in the room. Who's dealing with APIs that you didn't build yourself? Well, that's the majority at this point. So for all of us, you probably have experienced this hand. You just got to deal with however long that API takes to do whatever it is, right? You cannot directly fine-tune the performance characteristics of these APIs that you're using. So when dealing with a slow thing that you can't make fast, you'll have to think about the ways you can make that slow thing feel fast, right? So I've outlined 3 little things for that, for this presentation. First and foremost, communicate, over-communicate. Always show, the progress, show the status of what's going on at any given time. Make sure that your user is always aware that something is happening and that your app is still working. Any sort of user interaction without that immediate feedback can often result, in the user wondering, did it work? Did it just not notice that I tapped it? Did it freeze? Whatever. So for operations that are that sort of immediate window, 200 milliseconds to a second-ish, quick and obvious starting point, sort of humble spinner or a progress bar for something longer. Although that being said, may or may not be good enough. Sure, many of us have done this little trick where you put the cursor right on where the progress bar is, right? So you can still see, wait, did it move? Did it actually, am I going crazy? So for longer running processes like that, really consider telling your end user what is happening at any given time, right? Keep them engaged, keep them in the loop, give them that feedback. Actually, something happened last night at the hotel that I thought was a fun little addition for this section. So quick sidebar. I usually sleep with little earbuds that play some white noise, just especially for hotels. Pretty nice pro tip. But yesterday night, right before I went to sleep, there was like a prompt that was like, update available. Uh-oh. And there was nothing like a not now, please let me go to bed button, right? So during that first half of that process, keep in mind, mental state is now, I want to go to bed. This thing doesn't let me because there's an update. Not good. So in the first half of the process, there was a very clear set of instructions presented to me, right? It was saying, hey, this is going to take up to 30 minutes. Whoa, okay. And I have to leave my phone in close proximity to the thing because otherwise it cannot do it. And then it might take another 30 minutes after that. But again, I'm sure there's some sort of technical reason why that's the case, and the app designer cannot do anything about it, right? It's a technical restriction. However, on the screen, you got a progress bar, you got a percentage indicator, so it was communicating to me that stuff is actively happening, right? I can see the percentage thing move along, and it's sort of like, because of that, I was able to put it down and just grab my laptop, do something else in the meantime, check back in every now and again, be like, oh, we're at 80-something%, probably be another 10 minutes or so. Once it was transferred, though, it went to this screen, where it was just saying, oh, just look at the case and the sort of pattern of flashy lights, and that's it, right? So kind of similar to that subway example, the measured performance of these two steps was almost identical. Took about 15 minutes each on each end, but the perceived performance for me as a user in that second half was way worse, because now I had no idea if it was still doing it, if it was just sort of boot looping, or if it was just waiting for me. Did I recognize the flashing lights the right way? So the communication was pretty lacking in that sense. Then, all of a sudden I saw the lights on that little case just start blinking all over the place in a different way. So I was like, all right, that's probably my signal. Press the I think it's done-ish button. And then nothing happened. It was just like, oh, no, didn't work. Let's try again. I was like, whoa, okay, wait, did I do that? Was I too soon? Did I close the case? Did something fail? Was it the Wi-Fi? Was it the storm yesterday? I had no idea, right? But the one thing I knew was like, I wanted to go to bed at this point because we were 30 minutes in. And this said, let's do it again for another 30 to 45 minutes. I was like, let's not do that. So I just force quit the app. It's just this sort of like, I don't like what the app is doing. Let's just not. And when I restarted it, it was fine. It worked. There was no update found. So we were good, I guess. So, went to bed. And then 50 minutes later, that stupid alert went off. I'm sure a lot of you guys got it too, right? With the thunderstorm. Oh, well, what are you going to do? But similar example, right? Very different perceived performance, very similar measured performance. That's really the takeaway there. So what could I have done to improve that second half there? So if we compare that sort of transferring process to the case and then updating, it's actually kind of similar to dealing with large files, uploads, downloads. It's a very common example. But if we take a peek at WeTransfer, a service that deals with sending large files to other people, we can learn a lot from that kind of stuff. So in this case, you see that upload progress bar is simultaneously a spinner. Pretty clever way to sort of show that something is actively happening and you see the progress at the same time. But they're also showing, the amount of bytes that has been uploaded. So I have a very clear feedback loop of this is what we're doing, this is the next step, and how far we are in the overall progress. So adding something like this to that second half of that app flow just now would have helped me a ton as a user, right? Because then I'd be like, oh, this is going to be 10 minutes remaining. I'm going to just pull up a YouTube video or something else in the meantime. All good. And then that WeTransfer example also has like these full screen backgrounds. I mean, they're mostly used for ads nowadays, but it does give me something to look at and interact with as well in the meantime, which brings me to the second option there. Engage your user by, give them something to do. Give them something to engage with. Ideally, you can give them a partial result of whatever it is that you're doing without them having to wait for the whole thing to be done. Things like streaming HTML. We saw some progressive rendering earlier in the hydration examples, or by progressively loading images. That's a pretty common example now, right? So by progressively loading, you can start to show something as soon as it becomes available, rather than have to wait for the whole thing. It's pretty popular nowadays to show it when it comes to image loading. Maybe you've seen it on Medium before, or in this case, Unsplash, where you start by showing just, a blurred thing version that's like super stretched and blurred out, so you get a rough idea of what we're waiting for, and then it sort of steps into place when it's done, right? So this is a good example of that progressive rendering. In Unsplash's case, they use like an 8x8 bitmap sort of inline thingy. I've seen Blur Hash, maybe some of you have tried that out, or other mini PNGs or whatever like that. Browsers actually do this by default. I think it's a very interesting thing that we oftentimes forget. So if you stream HTML, that works natively. But for images as well, I mean, I'm sure you've all seen this before. If you open a large image file, it sort of slowly trickles in from the top, like a waterfall. And it's just because most images are encoded top to bottom. So the browser can start showing you them as soon as they come in. The one thing that a lot of people don't really use all that often, it's very underutilized as far as I'm concerned, is progressive rendering for images. So in JPEGs or PNGs or AVIFs nowadays too, you can re-encode them to sort of uniformly progressively load. So you start with a very blurry pixelated version first, and then it sort of progressively gets clearer over time, which is actually a very nice solution that's similar to the blur idea, just using, use the platform. When you're dealing with longer running processes, though, where you can't really progressively show stuff, consider just giving the user completely something else to do. Right? So a pretty famous example now is that little dinosaur game in Chrome. You're just waiting for the network to be available. It doesn't know how long that's going to take. It cannot tell you anything else in the meantime. So it just distracts you with a little game in the meantime, right? So Netlify actually does a very similar thing too. I don't know if you've ever seen that during deployments. There's a little button in the top right. It's like, you want to play a little game? I'm like, oh, yeah, sure. I have to wait, 30 seconds to 5 minutes anyways for this thing to be done. So I might as well, waste some time. The queue, the famous XKCD is like, what are you guys doing? Yeah, it's compiling. Yeah. Funnily enough, in this example, it's kind of a bit of both, right? Because it's showing you those logs as they come in very progressively, but then it also distracts you in the meantime with something else to do. Cool, then last but not least, for those three, predict. Predict what the user will do. If you can start doing things before the user even knows they want to do them, you can sort of cheat the system a little bit, right? So you make the loading time shorter by just starting it earlier. Of course, very more specific to how you're building your app, what it is supposed to do. It's also a little hard to visually show you on these slides as it all happens under the hood. But you see this often happen in search results. If you pull up a Safari to autocomplete, it will preload the first couple of websites so it feels instantaneous. Or prefetching page content. If you hover a link, you can start downloading the page underneath, and then when somebody clicks, it's already there. You kind of sort of cheat the system a little bit. Lucky for us Vue developers, our friends at Nux and Astro make that trivially easy nowadays to implement. Some even do it by default. You just use the Nux link instead of a browser link, and you sort of get this out of the box automatically. Good, great stuff. Great stuff. So with those techniques in place, you can make your app feel a hell of a lot more responsive than it actually might be, which results in a way better UX overall for your app. However, of course, there's a gotcha. Those solutions aren't really a catch-all improvement in every situation. So we tend to want to speed things up at all costs, but it's really not always going to result in the best end result, right? If you implemented all of the techniques that we just looked at to make your app feel faster, you might sometimes end up in an accidental state where the project actually is a way jankier to use than you had intended. That was actually a very real problem we ran into when we were building Directus. Because in Directus, we're rendering custom forms based on the data model of the database, and those custom forms are made up of individual Vue components. So each of the input types and each of those parts of a form are Vue components. So when it came to the measured performance of that form, it can take a minute because all of those Vue components themselves, we provide some out of the box, some could be plugins. So therefore, we got to load them in and show them on the page. So we figured to speed up the performance, let's use one of those great Vue features, make it an async component, right? I won't go into the tech too much, but Vue has that system built in, fantastic. It just means that you pull up the form, it asynchronously loads in the components and then renders them on the page for the first time, right? So the measured performance, the actual time to interactive and all that kind of stuff was pretty decent because now the page itself opens up immediately because we don't have to wait for the rest of the form. But the perceived performance, that experience for my users, really took a hit. Because for somebody on the internet, the experience was pretty rough, actually, because if you have a bit of a slower connection. So what we saw happening, on the very first load, the form would kind of show up, but it was just the labels, because the components weren't there yet, right? So then over time, fields would sort of show up one by one, jumping in and sort of reflowing the page, whenever that was happening. And then finally, the form would be ready to use. So again, the measure performance was way better because the page showed up in no time, but then the user experience just was not what we were hoping for. So to fix that, we were like, oh, maybe we use one of those nifty skeleton loaders because then it doesn't jump around, better experience. Skeleton loaders, the hip stuff, use it. So we did that, good stuff. Another bonus point for Vue for having stuff like that baked in. You can say, oh, this is the loading component to show while the actual component is loading. So we'll try that. So when you load it, same thing, still happened. Whoops. Turns out Vue.js has a default delay before it shows the loader. It's exactly on that instant window of that 200 milliseconds. But then after that, the form shows up made out of skeleton components. And then the fields sort of load in, one by one. It was just that image input jumped a little bit. We don't know what the height is before it's being loaded. So, perceived performance is way better than the previous one because now at least you can see the form. But still a couple gotchas, of course, because the user cannot interact yet with the fields until they're done loading. And for the users with faster internet speeds, it's like a very sort of fast, fleshy thing, right? You just see them all like show up like little lights. So how did we then resolve that issue? Well, we didn't. That was actually the honest answer. We just decided, you know what? We shouldn't. It's actually a better user experience to take a more native app approach by saying, when the user first logs into the system, we're going to preload all of those fields. So therefore, the experience for the rest of it is going to be way better, right? Than if they click around the app, it's already there. Because in most native apps, you don't really think about this when you're working in the web too much, but it's very common for things to take a minute, before they show up. So you see the little icon bounce for a couple of seconds, and then that's kind of like a spinner, right? And then an app shows up, but at that point, the app's there. You can click around, buttons work. You don't really have to wait from that point onwards. So in our case, in DirectX's case, that app is meant as a back-end administration app. So therefore, the measured performance, ironically enough, really isn't as important for the user experience of the rest of the platform. So we just decided, let's front load all of that stuff. Like the initial render of the login page, keep that lightweight, keep it as fast as possible. And then when somebody logs in, we have a moment where the user already expects to have a second to wait, right? So during login, we were like, if we move the loading to that moment in time in the user progression, the user experience is way better for the rest of the app after it. So it's a sort of strange moment there for, I was very performance-minded before that and using all the tools to be like, okay, I'm going to make it intentionally worse to make it better, right? So fast, not always strictly equal good. When faced with that choice of measure performance versus a good user experience should always come first. Biased user experience designer. And sometimes, like in that forum example, slowing things down on purpose can create a better overall user experience. And I think a great example of that nowadays is modern video games. Right? So I don't know if you've ever noticed this, but video games, they have to load and unload a lot of stuff all the time. Think of the level asset, 3D assets, textures, etc., etc. So video games usually stop the gameplay altogether, take you out of the immersion, loading screen, wait for a minute, everything is loaded in, and you're back in, right? You got to get back into that immersion. But you're seeing more and more big titles now in modern video games where they're kind of cleverly slowing the player down in such a way that in a controlled environment that they can start loading and unloading stuff in the meantime without the user really noticing that you're looking at a loading screen. So maybe if you're into playing video games, you might have noticed things like, doors that take suspiciously long to unlock with a little mini game, or you have to crawl through a rock formation, or suddenly there's an elevator that will take 30 seconds to get you somewhere, or you have to crawl through a vent, or things like that. It's all just ways to slow down that player to give sort of the game some time, to basically be a loading screen at the same time, right? So those clever slowdowns really, really help that user experience by keeping them engaged within the story in the game, even though the game itself is still loading a bunch of stuff under it that takes a while. Intentional speed bumps like that can be utilized on web apps as well, to keep the user engaged, make them understand things better, make sure they double check a decision, before they make it. I'm sure you might have noticed, if you use a chatbot nowadays, you oftentimes see a little typing indicator, even though it's a chatbot. I mean, it just gives you a predefined thing, right? So why is it pretending to type? Well, it's just to make you feel like you're talking to somebody, right? Or web shops show you your address so you can confirm, slows you down just to make sure that you know what you're doing. Next button on an onboarding thing that shows up after a couple seconds, just to make sure you've seen what they wanted you to see, right? Cool. So what did we do with all of that info? And how do you tackle all of this stuff in your own projects? Well, the sneaky, it's always, you never know. It always depends. It really depends on what you're doing, what your type of data is, what is the type of app you're trying to build. Is it important? Is it for public users? Is it kind of like us, a back-end only dashboard type of thing where it's okay to be a little bit slower up front? Long story short, be aware of this. I think that's really my main takeaway of this presentation. Just be aware of that perceived performance being so different from your actual measured performance. Take it into account. The main takeaways, though, importantly, user experience should always go over metrics, also over developer experience. Don't shoot me. important. And user experience, always more important than whatever metrics you might find. Try to make that slower stuff feel fast by using those techniques that we're talking about. And sometimes, make the faster stuff a little slower. Like slow down the user, give them a better experience, make sure that they understand what's going on. And don't be afraid, it's fine. If the user experience gets better, slow can be good sometimes. And with that, I want to say thank you very much for listening. It's been a great conference. If you want to nerd out a little bit more, we're right on the other side of the hall.